Well, here we are, Chapter 11, Topic 11.1 on permutations, from page 516 of our textbook. First of all, counting methods are used to determine the number of members of a specific set, as well as the outcomes of an event. You can display all of the possible choices using a table, using lists, or even tree diagrams, and then counting the number of outcomes. Another method of determining the number of possible outcomes is to use what is called the fundamental counting principle. The fundamental counting principle says that if one task can be performed in A ways, and a second task can be performed in B ways, then the two tasks can be performed in A times B ways. For example, a restaurant meal consists of 2 salad options, one of 3 entrees, and 4 desserts. So that would mean that there would be 2 times 3 times 4, or 24 different possible meal combinations. In example 1, arrangements with or without restrictions. A store manager has selected 4 possible applicants for 2 different positions at the department store. How many ways can the manager fill the positions? And then B, how many ways can a teacher seat 4 girls and 3 boys in a row of 7 seats if a boy must be seated at the end of each row? Here we go. In A, we can make a tree diagram. For the position 1, we're going to say we can have the choice of all 4 candidates, A, B, C, or D. But for position 2 now, if we hired A for position 1, that would leave us a choice of B or C or D for position 2. If we chose B for position 1, that would give us a choice of A or C or D for position 2. If we hired C for position 1, that would give us A, B, or D for position 2. And if we hired D for position 1, that would give us A, B, or C for position 2. Adding those up, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different possible combinations. Now, if we use the fundamental counting principle, we could say that there would be 4 different positions for A. Choices for position 1 would be 4. The choices for position 2 would be 3. 4 times 3 would give us 12 different possible combinations of hiring. In B, how many ways can a teacher seat 4 girls and 3 boys in a row of 7 seats? Well, let's draw out those 7 seats. Here's 7 seats with a boy at the beginning of the row. Here's what it is with a boy at the end of the row. And in between, we can have 4 girls and 1 boy in any order. So what we're going to do is we're going to say, this time we're going to put the possible combinations. Since there are, how many boys? 3 boys. We could have a choice of 3 boys sitting in the first position. If we picked boy A to sit there, we now have 2 choices to sit in the last position. And in between, it doesn't matter where anybody sits, so that could be 5 times 4 times 3 times 2 times 1, because anyone could sit in one position, the second position, and so on. So to figure out the total number of combinations, we'd have to multiply those numbers. And when you multiply 3 times 5 times 4 times 3 times 2 times 1 times 2, you will get 720 different possible combinations. In example 1b that we just looked at, the remaining 5 people, the 4 girls and the 1 boy, they can be arranged in 5 times 4 times 3 times 2 times 1 ways. This product can be abbreviated as 5 factorial. Therefore, 5 factorial is 5 times 4 times 3 times 2 times 1. And in general, our equation will be n factorial will be n times n minus 1 times n minus 2 times n minus 3 all the way down to 3 times 2 times 1, where n is any natural number. The definition of a factorial: for any positive integer n, the product of all of the positive integers up to and including n is going to be 4 factorial is 4 times 3 times 2 times 1, and 0 factorial is going to be defined as 1. In your turn, use any method to solve each problem. Take a moment to stop, do this question, and then turn it back on, resume play, to see what the solutions are. How many 3-digit numbers can you make allowing the digits 1, 2, 3, 4, and 5? Repetition of digits is not allowed. Well, here's what we're going to do. We're going to say in A we have 3 different positions. How many choices do we have for the first position? 5. That would leave us 4 for the second position, and that would leave us 3 for the third position. 5 times 4 times 3 would be 60 different. In B, how does the application of the fundamental counting principle change if the repetition of the digits is allowed? Well, in the first position, we'd have 5 choices. Since we can have repeating digits, we'd have 5 choices for the second and 5 choices for the third. Altogether, 125 different possible choices. The arrangement of objects or people in a line is called linear permutation. In a permutation, the order of the objects is important. When the objects are distinguishable from one another, a new order of objects creates a new permutation. 7 different objects can be arranged in 7 factorial ways. If there are 7 members on student council, how many ways can the council select 3 students to be the chair, the secretary, and the treasurer? Using the fundamental counting principle, there are 7 times 6 times 5 possible ways to fill the 3 positions. Using the factorial notation, 7 factorial over 4 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 factorial is 4 times 3 times 2 times 1, means that we can cancel the 4s, the 3s, the 2s, and the 1s, leaving us with 7 times 6 times 5, or 210 different possible combinations. The notation of NPR is used to represent the number of permutations or arrangements in a definite order, or R of R items taken from a set of n distinct items. The formula for NPR is it's equal to n factorial over n minus r factorial. N is any natural number. So here we go. If we did 7p3, it's 7 factorial over 7 minus 3 factorial, which is 7 factorial divided by 4 factorial, and that's going to give us the same R210. Here's how we're going to find this on our calculator. If you pressed 7, math, the right arrow 3 times, and then 4, you would have 7 factorial. Now if you divided this by 4, math, press the right arrow 3 times, and you pressed 4 again, and enter, you are going to get your solution. So those are the keystrokes you're going to use. Try it out now. Alright, let's practice this. Evaluate 9p4 using factorial notation. Well, 9p4 is 9 factorial divided by will be 9 minus 4 over 5 factorial, which is going to be 9 times 8 times 7 times 6 times 5 factorial over 5 factorial. And of course, the 5 factorials are going to cancel, leaving you with 9 times 8 times 7 times 6, which is 3024. B. Show that 100 factorial plus 99 factorial is equal to 101 times 99 factorial without using technology. Well, 100 factorial plus 99 factorial is got to be the same as 100 times 99 factorial plus 1 times 99 factorial. This would be 100 plus 1 times 99 factorial, or 101 times 99 factorial. Easy enough. Part C. Solve for n if np3 is equal to 60. Well, np3 is equal to 60 means we've got n factorial over n minus 3 factorial, which is n times n minus 1 times n minus 2 times n minus 3 factorial over n minus 3 factorial. Cancel out the n minus 3's, and you're going to get n times n minus 1 times n minus 2 is going to equal 60. If we multiply that all out, you can use trial and error to figure it out first of all. And if we did that, tried 5 times 4 times 3, we get 60. Then we found our solution using trial and error. We could also use algebra. N times n minus 1 times n minus 2 equals 60. Multiplying it, you're going to get n cubed minus 3n squared plus 2n is equal to 60, or n cubed minus 3n squared plus 2n minus 60 is equal to 0. Now, when we're solving a polynomial equation, remember, you can use the factor theorem, and you can try different values, factors of 60. When you get to 5, you will find that p of 5 is equal to 0. So the factor theorem says that 5 has to be our solution. Thirdly, you could graph this and find that the intersection point of our left side, which is n times n minus 1 times n minus 2, equals 60 when x is equal to 5. Here we're asked to evaluate 7p2 using factorial notation. Well, that would be 7 factorial over 7 minus 2, which is 5 factorial. 7 times 6 times 5 factorial over 5 factorial will give us 42. For B, show that 5 factorial minus 3 factorial is 19 times 3 factorial. Well, instead of 5 times 4, instead of 20, we're going to write 5 times 4 times 3 factorial, which is 20 times 3 factorial, minus 1 times 3 factorial, and that's going to be 19 times 3 factorial. For C, np2 is equal to 56. Well, n factorial over n minus 2 factorial is going to give us n times n minus 1 times n minus 2 factorial over n minus 2 factorial. Of course, those cross out, leaving us with n times n minus 1 is 56. N squared minus n is 56. N squared minus n minus 56 is equal to 0. Factor that to n minus 8 times n plus 7. Now, our negative we're going to be throwing away, so the only solution is n is equal to 8.